there! Let's talk about interpreting functions. This equation you see here, it's a classic equation for linear functions, right? Y equals mx plus b. We can also rewrite this to say f of x instead of y equals mx plus b. We're not just saying that x equals x and that if you solve this you get no solution. We're actually saying that y, instead of y, we're using f of x. In this case, we can write an input and output while still maintaining x and y, but instead of y, we're using f of x as a different way of writing it in function notation. And this is one of the most common forms using f of x. Let's say x equals 1. Let's say we have an equation f of x equals 3x plus 1. So x would be 1, and we solve the equation like normal. So 3 times 1 plus 1, that equals 4. We can do the same for 2 and 3, so we would get 7 and 10. It's just like a regular function, like a regular linear equation, except we are using a different notation to make this easier to solve for real-life problems. Now let's say we have actual problems. Let's say here. Let's look at this, but now let's input any number we want for x. Let's say we have, instead of x, let's input a number 5. So it's just saying f of x, so we're substituting x as a number. So we would put this into here, and we would get f of 5 equals 3 times 5 plus 1, which is 16. So f of 5 equals 16. We can do this for all kind of functions. And if we want to actually make these represent real-world problems, let's put it this way. We can easily turn this function into a real-world problem by just making x's and f of x's equal something. F of x equals the number of chickens, let's say, in our imaginary farm, and x equals the number of years after 2000, the year 2000. So let's think about this. We have x, which is the number of years, and we have it times 3. That's pretty much a multiplier, right? So let's say for every 1 year, that instantly means we get, let's say, 3. So if it was just 3x, the number of chickens would always be 3. So for every 1 year, we would have 3 chickens. And we also have it to be plus 1. So we would always get a consistent ratio of, for every, let's say, 1 year, we would get 4 chickens. Let's make our little table right here of x and f of x. Better get used to that notation here. So for 1 year after 2000, we would have 4 chickens. 2 years after 2000, we would have 7, and so on. And really here, we have a function that represents values, and this is what we really apply into the real world. Let's have some scenarios here. So let's say we have x equals 5. The notation we would use would be f of 5 equals 3x plus 1. And we know that 5 represents the number of years, just the 5. And if we plug it in, we would get f of 5 equals 3 times 5 plus 1, which is 16. Now we know that 5 years after 2000, we would have 16 chickens. From this, we can also notice that it's a directly proportional relationship. As the number of years increases, the number of chickens increase. We can analyze a lot of different components of a function by just looking at it and pretty much finding various parts of data. Now, let's say we weren't sure which is which. We didn't know which side was the chickens and which side would be the number of years. If we didn't know, the easiest way to find out is to make a graph. So let's say we have a little graph here, this side would always be x and that side would be y. We can also write it as f of x. Now, the horizontal line of the x-axis is always the independent. It's the variable that will change by itself. You have to put something into it for it to change. And the dependence variable is just what it says. It's dependent on the independence variable. So let's think back to those chickens and those years. So what do you put first? Do you put the chickens and then the year changes? Or do you put the number of years and then the amount of chickens change? Well, in this formula function here, we have the number of years first. Let's say if we put 1 year, then we know how many chickens there are. We can't do it the other way around so easily in a real life situation. So we would know that the number of chickens is dependent on the number of years. So let's put years on this axis. Years and chickens. And little crayons there. So we know that the number of years, or x, is always going to be independent. So we have 1 year, 2 years, 3 years, and so on. And the number of chickens is dependent on the number of years, which means it's the y-axis, which is exactly how we set up this function here. F of x is the number of chickens, and x is just the number of years. Keep that in mind, and you'll notice that a lot of times x is just the number of years, the units that we're counting, like feet, seconds, people, number, and so on. Alright, now let's move to a different problem and see how you can figure it out. Let's look at this problem here. Let f of x be the number of people who own a car x years after the year 1900. X and f of x. Alright, so we have f of 5 equals 130. That's our first problem here. Let's go back to the prompt again. F of x be the number of people who own a car after the year x years after 1900. Don't let that confuse you too much. Let's think back to that graph about chickens and years. The number of people should be dependent on the number of years, correct? So we have the number of years as our independent variable, our x here. And it even says right here, x number of years, and f of x, meaning after you plug in x, you get that value right there. So we know, even without looking at this, we know that f of x equals number of people, and x equals number of years. Now we can look at this and say, okay, f of 5 is the number of years after you plug it in. So we have f of 5, the number of years, so 5 years after 1900, which is 1905, there are 130 people. And this makes sense because the f of x right here is the x, which is the number of years, and what f of x is equal to, that's the number of people. Alright, now the next two, I'll let you think about it, so I'll pause here for a sec. Alright, so f of 10 equals 1500, that would be 10 years after 1900, which is 1910, equals 1500 people. So in the year 1910, there are 1500 people who own a car. For the last one, this is kind of your own make an inference thing based on the data, since this is a function of a standard ratio, assuming that it is a linear function. So f of x equals 3000. So we know that it's increasing, so it has to be greater than 1910, 10 years after. So if we think about it, we know that 3,000 is just twice of 1,500. So we can make an educated guess, a very good educated guess, that it would be in the year 1920, assuming that this is linear, but obviously it isn't, because 130 times 2 is not 1,500. So we can pretty much say that this is X is at least 10 years. Assuming from this path, it would be probably next year. Alright, so I hope that helped you interpret functions, and thank you for listening, and this is Interpreting Functions, provided to you by SATFreePractice.com.